the quiz review is pretty much exactly the same as what your quiz will look like next class. You will have to do all of the problems on this worksheet, but we're going to do the evens together. So for number 2, it says write a conjecture. Remember, a conjecture is just your guess or your observation based on the patterns that have been given. We're going to use that conjecture to find the next item in the sequence. So for example number 2, we have 4, which goes up to 10, 10 which goes up to 18, 18 goes to 28, and 28 goes to 40. So I'm just going to play around and see what happens to figure out how does 4 become a 10. Well, 4 becomes a 10 by adding 6. And then how does a 10 become an 8? Well, I'd have to add 8. And 18 becomes 28 by adding 10. And then 28 becomes 40 by adding 12. So what's happening here is that I'm adding 2 more to each previous additive. So for the next term, I would add not 12, but 2 more than that. I would add 14 to 40. So my conjecture is that each term is increased by 2, or 2 more than the previous term. So then that would make my next term 40 plus 14, which is 54. Okay, number 4. The sum, remember sum is to add. So if I add 2 numbers, that sum is always greater than either number. Well, example 4, or number 4, we're asked to find a counterexample. So I'm trying to prove that this statement is a false statement by providing a counterexample. So the sum of 2 numbers is always greater than either number. So basically that means what 2 numbers can I add together where their sum is going to be greater than both numbers? Well, anytime you add a positive to a negative number, the sum will be greater than the negative number. So 2 plus a negative 1 is going to give me a positive 1, and this positive 1 is greater than this negative 1, which proves that their sum, is not greater than 2. So it proves that their sum of 1 is not greater than 2. Okay, number 6, we're asked to take the statement that's given to us and turn it into a conditional. A conditional is an if-then statement. When you're making an if-then statement out of one that is not currently an if-then statement, it has to make sense. Just like you would speak to someone. You can't just leave out your pronouns and your subjects and your objects. You have to make it make sense. So I can't just put if all mammals then are warm-blooded. I have to refer to what a mammal is. Well, a mammal is an animal. So I can say if an animal is a mammal, then it is warm-blooded. The converse of a statement is to take your original conditional, which is P then Q, and just like the Converse shoes, you're going to do a backflip in your Converse shoes. So we're going to flip the Q and the P. So being warm-blooded will come first, being a mammal will come last. Once again, we're not making up a sentence that makes no sense. We want it to make sense. So we can't just say if it is warm-blooded. We have to address what it is. So if an animal is warm-blooded, then it is a mammal. The inverse tells us to insert a not, or to negate the original conditional. So if it is a mammal, if the animal is a mammal, we're going to negate that. So the animal will not be a mammal. Then it is warm-blooded will become it is not warm-blooded. We're going to negate that. So it should read, if an animal is not a mammal, then it is not warm-blooded. The contrapositive, that's our big complicated word, so we're going to make the statement complicated. We're going to first flip the original conditional, and then we're going to negate the hypothesis and conclusion. So original conditional was the animal is not warm-blooded. We're going to flip that. So it should say, if an animal is not warm-blooded, then it is not a mammal. And then finally, our biconditional, well, first we have to check, is the converse true and is the conditional true? Because we can only write a biconditional if both the converse and the conditional itself are true. So if an animal is a mammal, so think about a mammal. What do we know about mammals? Well, they have hair and they're warm-blooded. So if an animal is a mammal, then it is warm-blooded. That's a true statement. Okay, the converse, if an animal is warm-blooded, well, one of the things that makes an animal a mammal is that it's warm-blooded. So if an animal is warm-blooded, then it has to be a mammal. That's also true. So now we can write the biconditional of our conditional. The biconditional, we only take out the if and the then of our original conditional, and then we put an if and only if in between the hypothesis and conclusion. So an animal is a mammal if and only if it is warm-blooded. And if you recall, if we were to write that symbolically, it would be P double arrow Q, where that reads P if and only if Q. An animal is a mammal if and only if is warm-blooded. Okay, number 8, we are asked to write the converse. Remember, converse is to flip the hypothesis and the conclusion. We're going to write the converse of the following true statement and determine if it's true. If it is false, we're going to write a counterexample. Remember, a counterexample is just a statement that proves that your condition, or that your, in this case, converse is false. So we were already told that if I go to the movies, then I will eat popcorn, that's true. So we're going to take the converse of that. We're going to flip our original conditional. So first, if I eat popcorn, then I go to the movies. We're going to cut out the word will, because if I will eat popcorn doesn't really make sense. So we say, if I eat popcorn, then I went to the movies. Okay, so in order to decide whether that converse is true or false, we have to figure out, when is this true? When do you eat popcorn, but your conclusion is false? So when do you eat popcorn, but it's not true that you went to the movies? Well, I eat popcorn at my house, so I don't have to go to the movies to eat popcorn. So this is a false statement. So my counterexample that I would like to provide is, I can eat popcorn at home without going to the movies. So while the hypothesis is true, the conclusion is false. That makes the entire converse false. Problem number 10 asks us to write an all, some, or no none statement from the following Venn diagrams. So we have students in one circle and people who have jobs in another circle. Well, when you have two circles that overlap like this, it's generally a sum statement that we would write. So what I'm going to represent is this area here. This area here represents the students, the sum of the students that also have jobs. So my statement is that some students also have jobs, or just some students have jobs. All right, and then finally we have a 3-circle Venn diagram. And if you need a highlighter, please ask for one, but they really do come in handy when you have 3-circle Venn diagrams. Number 12, we want to know how many guests ordered all 3 foods. So separately, I'm going to highlight each category. These are the people that like or ordered hamburgers. These are the people that ordered hot dogs. And these are the people that ordered pizza. So if you notice, we want to know, where did they order all 3 foods. You have the blue encompassing the yellow, encompassing the magenta. So all three of these are surrounding this area here where it's two people ordered all three foods.